Hello everyone, my name is Krishna Datta and I am second year MTech student of Electronics and Communication from BIT Meshra. Today I am going to explain MOSFET and how it works. For this, you have to have the concept of doping, N-type, P-type materials, PN diodes and how they work. First, let us understand the structure of a MOSFET. So, a MOSFET, this is a 3D structure of MOSFET. So, MOSFET is a P-type substrate material over which two N-type wheels are constructed. One is the source terminal and another is the drain terminal, and over this substrate oxide layer, insulating layer is constructed, and this terminal is called the gate terminal. So the source, gate and the drain terminal are insulated from each other by the oxide layer, and the distance between the area between the source and the drain is called the channel area. So here we'll understand when the current is conducting, how what is the path that is taken in the MOSFET. The current passes from the source to the drain region. For this to happen, there has to be potential difference between the source and the drain, and also there has to be a conducting path between the source and drain region. For this conducting path, the gate is responsible. So a voltage and a positive voltage at the gate will ensure a channel between the source and the drain region. This is true for NMOS. In NMOS, we have a P substrate and N-type materials at source and the drain regions. Next, let's see how a MOSFET works. Let's take case 1. In case 1, we have taken the gate to source voltage as negative. First, we'll see. We set the source voltage as grounded as 0, and we'll increase the drain voltage VDS from 0 to high and see what happens. First, let us set VDS is minus 5 volt. So here we see that VDS is minus 5 volt. So this insulating region will ensure that a capacitive type of capacitance is formed here. So the gate is negative and the substrate is positive, and it is separated with the insulating region. So a capacitance is formed between these two regions, and when we set gate voltage is negative, so this negative charge will attract the positive holes towards it, and it will cause them to accumulate at the channel region. So the holes of the P substrate will start to come near the channel region and accumulate here. This will cause to form an insulating region or non-conducting path between the source and the drain at the channel region. This will obstruct any current to flow from here to here. Therefore, at VGS negative at minus 5 volt and VDS is 0, no current will flow, and the ID will be almost near to 0. But as we increase VDS, the ID will always remain 0, because however we increase VDS, this path will always remain non-conductive, so no current will pass from here to here. Next, let's take case 2. Here we'll increase VGS, will increase VDS, but VGS will increase from 0 to a small value, and let's see what happens. So as we increase VGS, increase VGS to a positive value, the positive voltage at the gate will attract negative electrons to accumulate at the channel region. This will cause to form a channel between the source and the drain. At a point, as we continuously increase VGS, there will come a point where the purely electrons will be present at this channel region. This will cause this point at this point the VGS value will be known as a threshold voltage, because at this point the current will start flowing from source to drain. And let's take, for this example, we take V threshold is 4 volt. Okay, and so at V threshold 4 volt the current will start to flow. At as VDS, let's look at this graph. As VGS is 0 and slowly we increase VDS. For VGS equals to 4 volt, the current will slowly start to flow. And as we increase VDS, the potential between the source and drain will also increase, causing the current magnitude of the current will also increase with this. And as we increase VGS to 6 volt, the channel region will also thicken, because because more number of electrons will be accumulated here. This will also increase the magnitude of the current at the same value of VGS. And so for VGS equals to 6 volt, more current will flow as compared to VGS equals to 4 volt. And as we increase VDS, the current will also increase as the potential is increasing. Same is the case for VGS. And as we further increase VGS equals to 8 volt, more number of electrons will be accumulated here, and causing more amount of current will flow at this value. Now we'll understand what happens after this point of VDS. Let's take the last case where at constant VGS, VDS will be increased. So let's take one case where VGS is 8 volt and VDS we take different values. So the drain to gate voltage we see is VDS minus VGS. So at every point the voltage value will be different, because the gate voltage is positive. So the voltage at every point will be different. So at VDS is 2 volt, we have fixed VGS is 8 volt. So at VGS equals to 2 volt, we put VDS equals 2 volt and VGS equals to 8 volt, and we get VDG we get minus 6 volt. And VDS, if we increase VDS, we see in this graph, if we increase VDS to 5 volt, VDG we get minus 3 volt. As we increase VDS, VGS VDG is also increased. As we increase VDS, VDG is also increased. Because of this, the field intensity at near the drain will also will decrease, and this decrease in intensity will cause less number of electrons to be accumulated in this region. As we increase this VDS, this channel gets slimmer and slimmer, and a point reaches where this VDG becomes 0. At this point VDG becomes 0, and this is called the pinch off point. So at a point where VDG has reached that point, the current will no longer increase, So this is that point. After this, the current will no longer increase. However, we increase VDS, the current will remain the same as this value, and it will remain constant. So we say that the current is saturated, and this value of current is known as saturation current, or in short IDSS. So finally, we see in this graph that this region is in this graph that there are 3 regions. One is this region where no current is passing, so this is known as cutoff region. In this region, the current is increasing. As we increase VDS, the current is increasing, so this we call the linear region. And the third, here, however we increase VDS, the current remains saturated at constant level. So this is known as saturation or active region. So here we understand the three regions of operations of MOSFET. Thank you.